Okay, so we were just going to do a very quick review on Gibbs free energy. So when we talk about Gibbs free energy, we're talking about whether a reaction is thermodynamically favored or spontaneous or not. So we have to really talk about three main things. We have to talk about the temperature, we have to talk about the enthalpy, so does it absorb energy, does it release energy, and then also we have to talk about the entropy. So remember, entropy is S, so the change in entropy, if it's positive, that means that we've created more disorder. If delta S is negative, that means that we have created more order. We've essentially cleaned the room. So anytime that we create more disorder, that is favorable for us. That makes us happy. Anytime that you have to clean your room, that makes you unhappy. So when we talk about delta H, if it's positive, that means that we have put energy into that system. We are lazy, we're chemists, we don't like that. That makes us sad. If delta H is negative, that means that we have released energy and we like that. So when we talk about Gibbs free energy, we talk about whether a reaction is going to be thermodynamically favored or not. Remember, it's going to deal with delta H and delta S. So if delta G is negative, that means it's thermodynamically favored, that is good for us. If delta G is positive, that means that it's not thermodynamically favored. However, you remember, if something is not thermodynamically favored, you can still make that reaction happen if you have enough energy, or you can couple it with something that will give it the push it needs. So when we talk about a solid, okay, when we talk about KSP, we're talking about whether that product, that thing is going to be insoluble or if it's going to dissolve or not. Well, when we think about this, we also talk about the reverse reaction. So when we dissolve it versus when we make that ionic compound. So if you remember the separation of the solute particles, so we are pulling ions apart. Anytime we pull things apart that are attracted to each other, that is always going to be an endothermic process. It takes energy to do that. So when we make a solution, we're going to separate our solute. We're going to also separate our solvent. So again, you're pulling things apart. That is an endothermic process. The last part is going to happen when you take the solvent and then you combine it with the solute. That is an exothermic process. So that last part is when we're putting things together that are attracted to each other. That always releases energy. When you pull them apart, it takes it. When you put them together, it releases energy. So when you have a solution being created, remember, you can have a solution that's being created and it takes more energy for those first two steps than the energy that's released in that last step. That's an endothermic process overall. Okay, so endothermic processes, those things require energy. That does not make us happy. So if that reaction, if that process does happen, that indicates that entropy is our leading factor here. So when we talk about making a solution, we're going from a very ordered state to a very disordered state. That is going to lead to an increase in entropy. So when we talk about free energy, delta G is going to depend on your S and your H, okay? And then, of course, if you have two competing items, the entropy is good, but the enthalpy isn't, or the entropy is going down, and then you are releasing energy, that really depends on the temperature. So if you have an ionic compound and it's dissolved, delta S is going to be positive no matter what. Okay, there is more disorder when you go from that ionic crystal lattice to a solution. Now, delta H is going to depend on how much energy is released in that last step versus the first two steps. So the thing that to note about KSP though, KSP, if you have a very small KSP value, that means that it's not a favorable reaction. So if I have like silver chloride and I'm dissolving it and I know it's not very soluble, okay, that means that I have very little product and I have lots of reactants. So that means that if my K value is very small, delta G is going to be positive. So that's something to keep in mind. If you have an insoluble compound with a low KSP, you're going to have a delta G that's going to be positive.